Alright, so this is going to be a very detailed video about F geometry. We're going to move step by step. We'll start with looking at the position, and then we'll move to talking about the radius of the great and the small circles. We'll go as far as talking about the time of different locations and determining the distance between two different locations. So let's just get into it. What you're seeing on the left, I've tried to draw my best just to demonstrate how the F actually appears. Okay, so don't mind my drawing there. Okay, so these lines that you can see that are smaller, I would say that are horizontal, we call them the latitudes. Then the ones that are longer, can add some more, can have some more. These ones we call them so I'll use the one that to avoid the confusion. We call them the longitudes. Okay, the one that comes to be at the center like this, we call it the Greenwich meridian, and then the central latitude is called the equator. Okay, just a few things that here you just thought you'd need to be familiar with even as we talk about this topic. Okay, now how do you give a position of a location? So I'll give you a quick example. Maybe even before that, I need to show you how we label the latitudes and the longitudes. Um, let's say this top part is 50 degrees, and then I need to mention that the equator is of course at 0 degrees, and then I put another latitude down there, maybe let's say at 50 degrees as well. How do we distinguish the latitudes? So you and I know the compass, right? We understand that what's on top there is on north, down, south, right? So that's the way it's gonna be. So this is the top part, so that is going to be north. Then what's down there is the south. So the latitudes are labeled with north and south. Okay, and then on the longitudes, you'd see that some of them are on the west, and then some of them are supposed to be on the what? On the east. So the Greenwich meridian as well, as you might guess, is supposed to be at 0 degrees, and then what's on the left is on the west. Okay, so for example, that would be, if it's 80, that would be 80 degrees west. Anything on the right side would be east. Okay, I needed to mention that. Now let's try to look at let's try to give an example. Let's say this line is since it's a longitude, let's say it's 43 degrees east, and then we know this latitude is at 50 degrees north. Now let's say we have got a location about this point somewhere there. Now we can see that that location or that area is at the intersection between the 50 degrees north latitude and then with the 43 degrees east longitude. So location or position is given as latitude, comma, yeah, it's given by the latitude, comma, the longitude. So that location would be 50 degrees north, comma, 43 degrees east. So that's how you give a position. Okay, that's how you give a position under F geometry. Now this is 50 degrees south. Now let's say there is a location on this longitude which is the Greenwich meridian at 0 degrees. So give a comment below. What do you think is the position? How do you give a position of this location which is occurring on this latitude and this longitude, the Greenwich meridian? Okay, so basically that's the first part that I wanted to talk about, just to introduce you to this, and just thought I would needed to mention how you give a position of a location. Okay, now let's move on and talk about the great circles and the small circles. Okay, so the longitudes are called the great circles. So these ones are called the great circles. Okay, you may have another one like that. So these ones are called the great circles. Okay, I thought I needed to mention that. And then the latitudes are called the small circles. So there's only one big latitude, which is the equator. The equator is of the same magnitude in comparison to the longitudes. Okay, because it has got, when you cut it into half, you're able to determine when you cut the equator into half, or I mean when you measure its radius and then draw a line, you end up cutting the f into its half. Okay, so the equator is the only great circle when it comes to the latitudes, but all the longitudes are great circles. So all the great circles, what's key about them is the fact that their radius is equal to the radius of the earth. Okay, so the radius of the earth, for any information, is 6,370 kilometers, which is also 3,437 nautical miles. So all the great circles, this is their radius. Okay, now the question would be, how about the small circles then? So the small circles, you have to come up now with a formula to determine the radius of a latitude. Okay, so let's do an example here. Let's do an example. So we understand this is the equator, and then let's assume we want to determine the radius of this small latitude on top there. How do we find its radius? Okay, so we can draw a line. From its center to the circumference of a longitude, and then again we'll draw a line from the center of the equator and join at the circumference, and then again a line from the center of the latitude to the center of the equator. Okay, so you have to agree with me to say this is the radius of the latitude, and then this is any point from the center of a circle to the circumference is the radius. So since this is the radius of the equator, it is the radius of the earth. And then this side, we're not interested in it. Well, what we're interested in is the fact that there is an angle there that is being made between the two radii, the radius of the latitude and the radius of the equator. Okay, so from SOHCAHTOA we're able to come up with a formula that can relate the two. So if we are to focus on what part of the SOHCAHTOA gives us this side, the small radius r is adjacent to the angle theta, then the big R is the hypotenuse. So that gives us the middle part. So cosine of the angle theta is equal to the adjacent, which is a small r, and then the hypotenuse, which is a big R. If you try to make the r, which is the radius of the latitude, it's going to be r cos theta. So this is a very useful formula. So this formula, we use it to determine the radius of the latitude. Of course, we understand the values. There are 3,437 if you're dealing with nautical miles, or 6,370 if you're dealing with kilometers. Okay, that's a second part or principle that is very, very cardinal to understand. And for practice, let's try to calculate the radii. Okay, by radii I mean we're making two calculations of the radius. So calculate the radii of the following, right? Just to, for first one, let's look at 60 degrees south, and then the second one 70 degrees east. Let's calculate the radius of these circles. Okay, so yeah, in kilometers. or nautical miles, whichever you're comfortable with. How should you go about this? How should you go about this? Okay, so the formula is very, very simple. So what's key before you even attempt to answer the question is you basically identify which one is a great circle and which one is a small circle. So let's draw our F. Now when you say 60 degrees south, the implication is going to be on the bottom there, like this. Okay, I'm very bad at drawing here. Okay, so that is what it would imply, 60 degrees south. So you can already tell that this is actually a latitude, so it is a small circle. So therefore the formula is going to be r cos theta, right? So if you are calculating in nautical miles, 3,437, and then cosine of 60 degrees. Okay, that's how you are expected to calculate for that one there. Let me just grab my calculator here. So cosine of 60, if you are good at trigonometry, you understand that's half. So 3,437 multiplied by cosine 60 is 0.5. So that's 1,718.5 nautical miles. Okay, if you are trying to calculate in kilometers, you use 6,370. And then we've got one more there. Feel free to pause the video and just attempt to answer it. 70 degrees east, where is it supposed to be? This side. Okay, so 60 degrees east. Is it a great circle? Is it a small circle? It's a great circle. Or 70 degrees, by the way. It's a great circle. So how do we calculate? Okay, I know most of you have gotten it wrong. So basically, a great circle, the radius is known. Okay, so you just give the answer. If it's nautical miles, 3,437 nautical miles, 6,370 in kilometers. So for great circles, the radius is known. It's the radius of the Earth. Okay, so that's how you handle this part. Now let's move on to the other part, to the other section. Alright, so under this section, we want to talk about the circumference of the great circles and the small circles under F geometry. Okay, so let's bring back our F. Don't mind my drawing. Let me do something better. Okay, so let's assume that's our F, and we understand the circumference of a circle is given by 2 pi r, right? 2 pi r. So equally here, when it comes to the great circles, the formula is going to stand. It will just be 2 pi r. So if you are given a longitude, or any longitude actually, the circumference is known. So it's just 2 pi r. So 2 multiplied by pi multiplied by the radius of the Earth, including the equator, of course, which qualifies to be a great circle. Okay, now for the latitudes, it's a different case, but it's very easy since you know the value of r there. So it's just going to be 2 pi. Now that's going to be r cosine of what? Cosine of theta. So the formula would be 2 pi r. Now you know that the small r there is r cosine of theta. So that's how you calculate the circumference of a latitude. So this is going to be very useful when it comes to helping us determine the distance between 2 points, because we are supposed to find it as a ratio of the circumference. Okay, in short, if you know the length of a circle in full, if they give you to determine the distance of 60 degrees part of it, it will be easy for you. Okay, now just a quick exercise here. Let's try to calculate the length. So let's calculate the length of 40 degrees west. Okay, so calculate the length of circle 40 degrees west in nautical miles. Okay, So I'll allow you to pause the video and just attempt to give us an answer there. How do we determine the distance of that circle? Okay, so hoping you've actually gotten it. Very, very simple question here. So what do we apply? What principles do we apply? So to calculate the length, you're just trying to determine the circumference. So 2 pi r. Now 40 degrees west, is it a longitude? Is it a latitude? So west is going to be on the left side. So this is a longitude. Okay. So therefore, if it's a longitude, you understand it's just a matter of you substituting what's known. So the value of r becomes big, then becomes the radius of f. 2 pi. The radius in nautical miles is what? 3,437 nautical miles, right? So that will help you to determine the answer there. Okay, simple and straightforward. Now, having talked about the circumference of the length of a circle, we'll now move to a very interesting concept which we are going to call the distance between two places. Okay. Alright, let's handle a very interesting concept of how we get to determine the distance between two places when you're given the latitude, the longitude. Okay, so the key point here is the fact that we understand that the circumference is given by 2 pi r if it's a great circle, and then for a small circle we understand that r is just becomes, we just add cosine of theta. Okay, so r is actually the radius of the earth, which of course is a constant given both in nautical miles and degrees. Okay, so in nautical miles we understand that the radius is 3,437 nautical miles. In kilometers is 6,370 kilometers. Okay, so how do we find the distance? So the distance is going to be given as theta over 360 degrees multiplied by 2 pi r if it's for a great circle, or if it is along the longitude. Okay, for example, if you look at this longitude here, points B, A, D, when it comes to us determining the distance between any of them, we're supposed to use a big R there. Okay, now when it comes to distance or distance along the latitude, for example C and D, that would involve us to use this one where we add 2 pi r cosine of theta. Okay, that is one formula. The other formula is where we actually get to apply the use of the nautical miles. Okay, where we would understand that the distance can be given as 60. Okay, so 60 multiplied by whatever degrees you have. Okay, the understanding here is that a degree is actually equivalent to 60 nautical miles. Okay, so if you've got 100 degrees, it means it will be 100 times what? Times 60. Then you get your answer in what? In nautical miles. These are the two formulas. So 60 multiplied by the degrees, or theta in other terms. Now, how you find this theta in these two cases is what is very significant for you to understand. Now, let's try to observe what the diagram we have on the left. If I look at points A and B, they are all part of the north. Okay, so how do I get to determine the angle theta when it comes to me determining the distance between them? So if you are dealing with the same pole, or the same sign, or whatever you can call it, if you are dealing with the same pole or like poles, you subtract, because you would agree with me to say if you are measuring the distance from 40 to 80 degrees, it's north. The difference will give you the distance between them. So we're going to have 80 minus 40, which would be 40 over 360 degrees multiplied by 2. Your pi is on your calculator. The radius there, if you want to calculate use in kilometers, you use that. In nautical miles, you use that. Okay. The other way would be 40 degrees multiplied by what? Multiplied by the 60, which would give you the answer directly in nautical miles. Okay. So that's my explanation for that part. Very, very simplified, right? So that's how you deal with like pose. Okay. So of course, if you've done your calculations, that should be able to give you a value of 2400, okay, in nautical miles. So 2400 nautical miles. Now the other thing that we have to understand is how we handle, how we deal with opposite poles or different. Okay, so one example is if we try to look at A and E. In this case, we have seen that A is 40 degrees north and then E is 20 degrees south. How do we determine the distance between them? How do we determine the distance between them? So we understand that when we reach the equator, we reach 0. So from A to the equator it's 40 degrees. From the equator to E it's 20 degrees. Okay? Although my diagram doesn't correctly represent or show that. So you would understand that actually for us to get the accurate distance between them, we're supposed to add. So if you've got opposite poles, add. So 40 degrees plus 20 degrees would give us 60 degrees. And if I'm trying to calculate nautical miles, I'll just say 60 times 60, which will be 3600 nautical miles. Okay? So 60 degrees over 360 again is what you should be able to expect. So 60 over 360 if you are trying to use the other formula, and then 2 pi r, which is of course 6370 if you're dealing with kilometers. Simple and straightforward, right? I hope we're getting somewhere. Okay. And then the other thing that we need to now look at is how we calculate the distance along the latitude. So that would be one good example would be focusing on C and D. Okay. So C is along a longitude of 40 degrees west, and then if I given us, so for this longitude where these other points are, I forgot to give you, it's 20 degrees east. Okay, so you can actually see that they are also of opposite sides, so you just basically add them, which will give you 60 degrees again. So you use 60 as the theta. Now it would be 60 degrees over 360 degrees multiplied by 2 pi. Now r, now this is a latitude, so it would be cosine of theta for us to determine accurately the radius of the latitude. Okay, so that's how you can easily determine the distance of the distance between the points C and D. Okay, so 40 degrees, and then look at the 20 degrees east there, you'll be able to get the angle that we're actually looking for. Is there anything else that I haven't covered when it comes to calculation of distance? Okay, I think this is sufficient. Okay, so for your practice, I want you to attempt to answer this question. So I want you to find the distance between D and E, and share your answer in the comment section below. Okay, so that's it to this section. Alright, so we'll look at a very interesting concept. This is determining the speed under F geometry, a very, very interesting concept. So a jet flew from point 30 degrees south, 30 degrees east to point B, which is 30 degrees north, 30 degrees east in 4 hours. I get the speed in knots. So when you look at the word knots, don't be shaken. You know, this is a very simple word. It just means nautical miles per hour. Okay, so the first step is just to determine the distance. We understand speed is distance over time. So if we can find the distance, we divide by the 4 hours, we would get our distance or our speed in knots. So the distance, we understand the shortcut or the fastest way of calculating the distance when it comes to nautical miles, we use 60 multiplied by the degrees, right? Or the theta, the angle theta. So how do you do that? So we have to understand what we are looking at here. We've got 30 degrees south, 30 degrees east. So this point, is it along the longitude or is it along the latitude? So that's very, very key as well. So the sharing or the common point that they are sharing is what? Is the east, 30 degrees east, 30 degrees east. So east is on the right. So that is a longitude if you are to draw the circle, right? So let's draw the Earth. If we are to demonstrate or show where the 30 degrees east is, so maybe somewhere there. So this is on the east. So one is 30 degrees south, so somewhere there. That is point A. The other one is point B, 30 degrees north. So we're trying to determine the distance between them. So distance between them, we're supposed to take into consideration their radius. In this case, their radius, this is a great circle, so the radius would be 3,437 nautical miles. So if you want to use the longer route, you use theta over 360 degrees multiplied by 2 pi and then the radius r, which is 3,437. The shortcut is 60 multiplied by the theta. The theta is now can be determined in two ways. If you're dealing with like poles, or if they are existing on the one half, it's north north or south south, you're supposed to be you're supposed to make it interesting for yourself, right? In that case, you just subtract. Now in cases where they're on the opposite side, one is in this case south, other one is north, what do? You basically add them. So yeah, they're going to give us 60 when you add 30 plus 30. So 60 times 60 gives us 3,600 what? Nautical miles. You should expect to get the same answer if you use that other formula. Now when you get the distance, you should now just divide by what? Just divide by the hours, which were 4 hours. Okay? And then if you divide 3,600 divided by 4, 900. So 900 knots was the speed. Okay? So if you are not sure, if you've not understood how to go about calculation of distance properly, watch my video on that. I think I explained very, very well on how to go about it. And then you'd apply that same concept. Okay? Now think of the question which is having point A as it is 30 degrees south, 30 degrees east, and then we get to say they are along the same latitude. So that would imply 30 degrees south and then 60 degrees east. Okay, kindly calculate the time or calculate the speed in knots as well if it took 3 hours. Alright, that's it. One of the most interesting concepts when you're discussing Earth geometry is time. Okay, so when you look at the Earth, if I was to draw a rough sketch of the Earth, one thing that you need to understand is time only changes when you change the longitude. So everybody who stays or whose location is on the same longitude share the time. Okay, so what would just make the difference is changing the longitude. Okay, so now each time that you actually make, or where there's 15 degrees difference, 15 degrees difference is equivalent to a 1 hour difference in terms of time. Okay, that's very, very key. So that would imply that if we're trying to determine the time, all we just need to do is just understand the difference between the longitudes, okay, which we've already discussed. We said if you're on the same side or on the same pole, just subtract. If you're on the opposite poles or different poles, you actually add. Okay, so now let's try to apply that concept to answer these questions. So let's determine the time at A and B, given that the time is 6 hours on Tuesday for point A. Can we determine the time for A and B? Okay, So now when you look at A is 40 degrees north and then 60 degrees east. So this is somewhere where A is. So A is somewhere there. The latitude is 40 degrees north. And then the longitude is 60 degrees east. Now we're told point B is 40 degrees north as well, but then it's 90 degrees east as well. So it's somewhere after A, somewhere there, 90 degrees east. So that's a difference. They've got different what? They've got different, let me even draw it there. So we've got different longitudes. One is 60 degrees east, the other one is 90 degrees east. So they are on the same pole. So the same pole, to determine the theta, what do? You subtract. So 90 minus 60 would give you 30 degrees as your theta. Now you understand that 1 theta or 15 degrees basically gives you 1 hour. Hour about 30 degrees. So you see that 15 degrees is actually twice in 30. So that's a difference of what? 2 hours. So 2 hours difference. And then as you move towards the right or towards the east, time actually increases. So point A, the time is going to be 8 hours. Okay. To make things interesting for you, I want you to pause the video and try out B. What do you think would be the time at B? 40 degrees north, 15 degrees west. So it's on the opposite side. So what do? So it's somewhere here. Okay. So what do? So since they're opposite, you add 60 plus 15 degrees, which would give you what? So that would give you 75 degrees. And then use 75 degrees. How many 15 degrees do we have in 75? You get 5 hours difference. 5 hours plus 6, that gives you 11 hours for point B. That's it.